Hello professors, and welcome to this educational session aboard the Science Bus. In these videos, in partnership with Wasibo, I will demonstrate the various experiments that can be performed utilizing the Science Bus kits. In today's experiment, we shall observe how to calculate the volume of a solid body through the process of immersion. For this particular experiment, you will require the mechanics kit, and this topic is appropriate for middle school level students. We carefully pour the liquid into the beaker until it precisely reaches a total of 200 milliliters. Utilizing the caliper, we meticulously measure the base diameter as well as the height of the cylindrical mass. This particular procedure will let us to accurately determine the volume from a geometric standpoint, which involves pi multiplied by the radius squared and then further multiplied by the height. Subsequently, we will submerge it into the beaker and carefully observe the final volume that the water ultimately reaches. In this manner, we possess the capability to compute the volume of the object that is submerged within the beaker by determining the difference between the ultimate volume attained by the water and the initial volume, and subsequently observing the discrepancy with the geometric formula. To proceed with the comparison between the volumes obtained, the volume measured in milliliters and the volume measured in cubic centimeters, due to the accurate measurement with the caliper, we should perform an equivalence. To transform from milliliters to cubic centimeters, it is essential to recall that specifically for water, the correlation is that 1 liter of water occupies precisely 1 cubic decimeter. Let us conduct the experiment once more, this time using a different cylindrical object but without a loop to achieve enhanced precision in our calculations. Utilizing the caliper, we once more measure the diameter and the height, allowing us to calculate its volume from a geometric perspective. Let us immerse it in water and observe the final volume achieved in the beaker. We are thus able to calculate the volume of the cylinder in milliliters, and thanks to the equivalence, we would be able to convert the volume from milliliters to cubic centimeters and compare the two measurements. Let's now take the iron cube and use the caliper to measure its side. This way, we will be able to calculate the volume from a geometric perspective, which is equal to L cubed. Let's carefully immerse it into the beaker, ensuring that we do not splash any water, then gently tilt the beaker and closely observe the final volume level reached by the water. By utilizing this method, we are able to ascertain the volume of the cube through the process of immersion. Once we establish the equivalence, we will possess the capability to compare the two volumes that have been acquired. This particular experiment is quite fascinating as it enables us to determine the volume of irregularly shaped solids, such as this piece of quartz. Let's carefully immerse it into the beaker and closely observe the water level. We are thus able to calculate the volume of this solid, which is not possible from a geometric standpoint, as it has an irregular shape. Additionally, we have the capability to replicate this procedure for this particular shell.